My name is Tom Rummage, Senior Applications Engineer here at Micro Measurements. And today we're going to talk about something we've got a lot of requests from out there in the world about, a thin-walled pressure vessel and how you would apply a strain gauge to that and some of the mathematics that might be associated with that. We have here a clandestine thin-walled pressure vessel from an unknown manufacturer or unnamed. First thing I'm going to do is with any installation of a bonded foil strain gauge, you're going to start by degreasing the part. Now I'm going to use GC6 because this clandestine part is a little bit more sensitive to the aggressive solvents. So I'm going to use the GC6 and remove the oils of my fingers and that sort of thing. The next step will be we'll go directly to a wet abrade, and by the way, this is our GC6. A wet abrade with the conditioner A. It's a mild phosphoric acid solution which helps us to remove the paint and also begin the operation of getting the surface to the proper surface roughness. So I'm going to take the conditioner A and I'm going to put it on the silicon carbide abrasive paper, and then I'm going to lightly, because the can is very, very thin, thus a thin-walled pressure vessel, don't want to abrade too far. I might end up with a product on my shirt that I don't want to have on my shirt. So I'm giving it a nice thorough cleaning of the paint. And once I get past that, I'm now going to take a clean dry gauze sponge and I'm going to absorb the excess debris, if you will. And now I'm going to go to the conditioner A and a scrub with a cotton tip applicator, CSP1. This is going to remove the loose debris and further etch the aluminum that I'm bonding to. You'll notice it comes up with a little bit of the color because it's still got a little paint there. After the first step of wet abrading with the conditioner A and the 400 grit silicon carbide abrasive paper, the SCP3, I'm now going to take the conditioner A and a cotton tip applicator and I'm going to scrub the surface. This removes any loose paint or any leftover debris from the abrasion operation, the wet sanding. And you'll notice it comes up pretty dirty, so I want to turn it over and start again. I don't want this material to dry on the surface because it'll just recontaminate it, so I'm going to take a clean dry gauze sponge and with a single wiping motion I'm going to absorb the excess conditioner A off of there. Now we've got our surface prepared in terms of roughness and or it's chemically clean. We now need to get it to the proper pH. We're going to use our neutralizer 5A. If we didn't use this material and we continued with our M-Bond 200, the likelihood of a success is about 0. It does not like, our M-Bond 200 does not like an acidic surface. So now I'm going to take the neutralizer 5A, flood the surface with that, and scrub with a cotton tip applicator. Notice I'm putting my finger near the end of the tip of the cotton bud so that I can put some mechanical pressure down without distorting the cotton tip applicator. Alright, again the last step will be a clean dry gauze sponge to absorb the leftover neutralizer 5A. Don't want to leave that stuff behind. And we now have the surface prepared for bonding. So I'm going to set the can aside. I'm going to take a glass plate, and the reason we use a glass plate is 1, it's easy to tell if it's dirty, and 2, it's real easy to clean. But in this case it's relatively debris free. I just need to take some of the neutralizer 5A, the blue tip bottle, a couple of drops of the neutralizer 5A on the glass plate, and I'm going to scrub it. This removes any contamination from the surface of the glass plate, so that when I lay the gauge out to prepare it for bonding, I won't contaminate it. We're going to be using an Advanced Sensors technology strain gauge. It's a CEA 13 125 URA-350. Now this particular gauge, the URA, indicates it uses the advanced sensor technology to adjust the resistance. Now those of you who are used to the 125 UR and you're worried about what that A is going to do, It is identical in form, fit, and function. You won't know the difference. If you look very close under a microscope, you'll notice the adjustment technique. But this is the gauge we're going to be bonding. So I'm going to open up the gauge package. And using my blunt nose tweezers, I'm going to take that out of the package and lay it aside. Now, because we're extra fastidious with anything that touches the bonding surface of the strain gauge, I'm going to take the neutralizer 5A and put it in a gauze sponge, and I'm going to chemically clean the blades of my cotton tip applicator. Now that I've chemically cleaned the blunt nose tweezers, I'll splay open the acetate folder, and with all strain gauges, where do you grab it? You grab it by the corner on the tab end. Notice there's a shiny side and a dull side. I'm going to have the shiny side up. Now I'm going to, lack of tradition, I'm going to lay the gauge down so that I can attach the tape, the gauge handling tape, across its long axis. Next step, I'll take some PCT 3M tape. I'll pull off about 1.5 inches, 2 inches of it, because it might have been contaminated, and throw it away. I'll pull off another strip about 2 or 3 inches. I'll tape over the ends to make nice little convenient handles to take the tape back off when I'm finished. And with the shiny side up, I'm now going to entrain that strain gauge to the gauge handling tape. Now notice we're using a 3-element rosette. And to be honest with you, the principal strains on this can are going to be in the Hooke direction and the axial direction. And we know by theory that the Hooke direction will be twice the microstrain or twice the strain as the axial direction. We're going to use a 3-element rosette and prove that. So now I'm going to set my gauge on my glass plate somewhere aside. I'm going to bring my can back into view, and I'm going to lift at a shallow angle. Notice if I lifted at a steep angle, I might damage the gauge. Pull it off the glass plate. And then I'm going to position it in the center of my prepared area and near the center of the can's section. And is alignment critical? Because it's a 3-element rosette, I'm going to calculate the angle from grid 1 to the maximum min principal strains and maximum min principal stresses. As a matter of fact, this particular exercise is used a large amount in our academic organizations. They will calculate what the pressure was in the can by depressurizing it and using a 3-element rosette to calculate the maximum min principal strains, and with the material properties of the can, the maximum minimum principal stresses, which allows you to calculate the PSI of the final pressure. Remembering that when you depressurize a can, it's going to go into compression rather than tension, which would be traditional when measuring pressures, but you just remember to reverse your sign. So, next step, lifting at a shallow angle. I'm going to expose the bonding surface of my strain gauge. I'm going to use the catalyst C. The catalyst C is to call it a catalyst is really not true. It's more of a controlling agent. And I'm going to, on the inside of the neck of the bottle, I'm going to hit it 8 to 10 times. I'm going to remove almost all of the catalyst C. And with a single wiping motion, I'm going to wet the backing of the gauge. I now must wait a full 60-second minute. Again, the academics use this in projects where they will estimate the pressure of a can once it's been depressurized. We're using a 13 STC so that there's no, even if there's a change in temperature, we won't have a lot of thermal output. And that pretty much is it. And we're very close to our 1 minute. I'm going to be using our M-Bond 200. It's a cyanoacrylate adhesive system, instant setting, and essentially what that gives you is 1 minute under your thumb, 2 minutes under the tape, and you're ready to use that strain gauge. I'm going to rotate this around so that you can see it a little better, and I'm able to run that direction with my wiping it clean. I'm going to get out a clean, dry gauze sponge and have that at the ready so that when I squeegee the gauge around, I can use that. I'm going to pick up the edge of the gauge Opening up the M-Bond 200 cap. And I'm going to take this and I'm going to put a single bead of adhesive right there at the cusp of the tape and the can. I'm going to hold the tape taut in the other direction, and then with a single wiping motion, squeegee through it, and then follow with my thumb. Now you're wondering, what is the proper clamping pressure when you're using your thumb? If you look at your thumb, it's going to be about 1/3 to 1/2 of a white thumbnail, depending upon your blood pressure. And I'm going to hold this down for another full 60-second minute. Don't short circuit this or you'll end up bonding the gauge again. These materials, with a large number of other materials, are available on our MM shop. That's our new online store. It's available for you to be more convenient. You don't have to fill out a purchase order. You just send in your order. You put in your secure method. You put in your credit card information or however you're going to pay for it, and we send the strain gauges and or accessories to you. Okay, I've now finished my 1 minute of clamping pressure with my thumb, and if you watch, I've stuck myself to my can. This is unavoidable in some cases when you have larger strain gauges and the adhesive. So if I pull straight up, I'm going to pull off a chunk of my thumb. I really don't want to do that, so I'll rotate my thumb. And the oils on my skin are a natural release agent, and I'm now free. And at this point, we have to wait 2 more minutes under the tape. All right, we've gotten to our 2 minutes of time underneath the tape, and now becomes find out whether we really bonded the gauge or not. As we lifted it at a shallow angle before to avoid damaging the gauge by bending it, we're going to peel it back 180 degrees on itself to put the adhesive system into shear so it doesn't pull the gauge up. Not terribly good in peel, but excellent in shear. And now I'm going to do a close visual inspection. I'm looking for any discontinuous color underneath the gauge indicating a lack of adhesive or uneven or a bond line that's not complete. Looks like it's a pretty good setup here. I've got a little bit of a fillet around the outside of the edge where the adhesive flowed out. So now I'm ready to tin the tabs on the gauge. I have some 361 A20R solder here. I've got our new Mark 10 soldering station, which I'm not going to show you. Clean the tip and then thoroughly flood the tip. This gets rid of any oxidization that was on there before and makes your soldering operation so much easier. I'm now going to start on the left-hand side from me and work to the right. Place the solder in the target area, press the iron firmly down, add fresh solder and flux. You too can become a soldering pro. All it takes is about 30 years of experience. No, a little bit of practice and you'll become as good as this in a couple of weeks. Last step, be sure when you finish soldering, clean that tip thoroughly and then very thoroughly wet it with solder. If you do not do that, you'll end up with a crusty or corroded tip, and your soldering operations will become exponentially more difficult. Next step is to attach the lead wire system. We're going to use a 3-wire quarter bridge setup. And so to do that, I have twisted the black and white together and tinned those, and I've got the red by itself. And I'm going to line those up on my can. Now, my rule of thumb is red goes to the right. When I used to race motorcycles, that's how I did it. So what I'm going to do is I'm going to take a piece of the paper drafting tape. I'm going to put it at the junction between the tape and the exposed conductors. And then I'm going to position that over the tabs of the gauge, using my tweezers for final positioning. And then I'm going to go ahead and reflow each one of them as I attach the wire. So clean the tip, lightly tin the tip, place the solder in the target area, add fresh solder and flux, and you too can solder your connection. I'm now going to move to the next one, which is right next to it. Again, using the paper drafting tape temporarily. Now note, I'm stacking the paper drafting tape up. I'm not trying to take it off after each one. We'll take care of that in one operation at the end. Again, we take our tweezers and line things up. Clean the tip. Lightly tin the tip. Add fresh solder and flux. And reflow the junctions. Last one is just like the other two. If you need to, like in my case, you can manipulate the wires just prior to putting them down. And we're going to reflow those solder junctions. All right. We've completed our soldering operations. I'm going to go ahead and turn off my soldering station. Never leave it on unnecessarily. And the solder is okay, but flux, he's not your friend. Once you've used him during the soldering operation, he becomes a double agent, wants to hurt you. So we're going to use the rosin solvent, and we're going to do two things. We're going to break down the mastic of the tape so I can easily remove it, and we're also going to begin the process of liquefying the flux and blotting it away. So take the rosin solvent. First thing I'm going to do is I'm basically going to flood the surface of the top piece of tape. And just to be sure I'm getting in there, I'm going to go ahead and start wetting those solder junctions. Take those tweezers, and peel off the tape. It should just float out of the way. If it doesn't float out of the way, then add some more rosin solvent to make it break down even more. And as you're sliding the wires, the tape from in between the wires, you might have to wiggle it a little bit to get it to come loose. And the final piece of tape, again, you have to wet it pretty good so it breaks down the mastic, makes it less aggressive, and allows you to take your tweezers and basically float that piece of tape out of the way. Now that we've paid attention to the tape and got it out of the way, let's pay attention to the solder junctions and work in and around those. The flux becomes a little crusty and or hard, and you want to work in there with the bristles of the brush mechanically to get that stuff out of there. Go up underneath the lead wires, take a clean dry gauze sponge, and blot the excess away. And you're going to want to do that 3 to 5 times, depending upon how long the installation is supposed to last. The longer you want it to last, the more thoroughly you must remove this flux to avoid drift or instability of the strain gauge with time. The last thing we're going to do is take some of the paper drafting tape, and normally I would do a little inchworm loop here, but because the wires are in such close proximity and this particular test is not going to take very long and won't have very high elongations, I'm just going to tape the 3 lead wires down. So taking the paper drafting tape, about 1.5 inches, 2 inches, it's not critical, and just away from the gauge, I'm going to tape it into position. The final step, which we would normally do after checking out the electrical characteristics of the strain gauge, would be to put down our environmental protection. I have already tested this offline, and therefore I know there's no problem, so we're going to go ahead and use the M-Coat A, and I'm going to coat the strain gauge. Paying special attention here at the lead wire connection, the solder junctions, because that's where typically things will begin to fail. And I'm just putting a light layer. You're not show car finish, you're not looking for that, you're just making sure that you've coated the part, protecting it both mechanically and from the debris in the air. okay, screwdrivers and or dust in the air. We'll allow that to finalize its cure, and we will put it into the chamber of doom where we test our pressure vessel